Hi, welcome to another episode of the Mighty Code Coder. I am your code coder. I'm here to make you great, help you innovate. Today we want to talk about a very serious topic. We call it the computer science conundrum. We are faced with lowered enrollment even in this day and age, 2018. We still definitely have an underrepresentation of females. Females make up 50% of our population, and yet in computer science, we still hover around 20% female population. So, what I did is make a Google slide to identify the problem, come up with a solution, and put it into a plan. So, let's take a look at that PowerPoint. All right, I call it Why Buildbox. Why now? The computer science conundrum. Buildbox is a software, it's a game engine that I'm introducing into all my computer science classes because it is a blocky based graphical language software that kids can easily drop and drag blocks of code. It's abstracted to the highest level, and it's kind of a beautiful software. So that's going to be one of my solutions to try to attract more girls to the discipline. But I think it's going to attract more people in general. It's a great program. Let's identify the problem first. All right. So then offer solution and then come up with a plan. All right. Here's the problem. Obviously, computer science has an underrepresentation of female students. We've noticed this probably since 2004, maybe earlier. Later on, Dan Garcia from UC Berkeley is going to talk, and he's going to identify the problem all the way back to 1993. So we'll talk more about that. But there definitely is an underrepresentation of female students, and we need to try to address it. Others have. We are too. For the data, the data to prove this, I will just simply go over my enrollment in my classes currently. I have 4 classes. It's a computer science pathway, my capstone class, my very highest class, meaning this is the class that everyone comes into when they're done learning how to code or program. It's video game development. Remember, what we're trying to do is create something at the end of their term that they can produce, get into the app store, a product. And so video game development, we figured we could do that. We could have the kids code a game, get it in the app store, have a product that is now given to the world. In that class, we have 27 students and only 3 are female. The next class down is Computer Science A. This is a College Board class. I have 13 students in their total. That's a dilemma right there in itself. And of those, there's only 3 that are female. Now, there's good news about that is that we're up 1 from last year. Okay, so 3 females and only 13 students total. And that's one class at my school. And we have 3 high schools in our district, and this is the only class in the district. So one class of 13 district-wide. AP Computer Science Principles. Now later on we're going to talk to Dan Garcia of UC Berkeley about his new course called The Beauty and Joy of Computing. That course turned into AP Computer Science P. We have it here at our school. We have 34 students, one class, 34 students, 7 are female. And then my freshman intro class. Our intro class, I call this I class, and we'll talk about the name of a course. That might be part of the solution also later on. That's why I bring that up. But we have 2 classes of that, 33 students on average, and we average 10 girls. Okay, so you see, identify, even though that's, just under, just around 30%, you see that we have a definite problem throughout all courses of attracting females. All right, so my solution is this. I feel that if we create curriculum that lets girls become engaged in constructing meaningful projects in a beautiful world, it would be meeting them where they're at. Okay, so their culture is to deal with projects that are worldly and are beautiful and if we can do stuff like that, maybe girls would be more attracted to computer science. So we looked to Dan Garcia of UC Berkeley and his course, The Beauty and Joy of Computing. It was developed by UC Berkeley professors, and I believe they went outside into industry and got some people to help out also to deal with inequality in CS. Here's a segment from what Dan says.
The space for introductory programming in a text-based language is pretty much dead. There's such a sweet spot pedagogically for having it be a block-based graphical language, or you're dragging blocks and you're kind of stacking them together. This comes from the Lego folks. This comes from Seymour Papert. How can we do this in a way that just makes sense to early learners? And so a graphical language makes it easier. You don't have to memorize the commands anymore. You can have no syntax errors because you try to drop a block onto this block, it doesn't.
So as you can see, the key points there, the space for introductory CS courses in a text-based language is dead. So to throw freshmen in class and start throwing text-based HTML, CSS, JavaScript, Python, that's really difficult. It's a tough hook to get kids going. So this graphical-based language is something that is easier for them to attain. It's very abstracted. And that came to us from Seymour Papert. In fact, Papert's ideas became so well known in the tech discipline that he wrote a book called Mindstorms, and Lego actually used the name of that book for their robotics computer science brick called Lego Mindstorms. So pretty cool. The new term also graphical language. Buildbox also has that blocky type of code, and this is a picture of it. Basically, what happens is when you drop a block or a node into the program, there's a block of code behind that. I believe this is actually blocky design patterns too, by the way. So it's really neat to see how the blocks of code connect to one another with these lines. And again, we introduced a new phrase in computer science called block-based graphical language. I mean, we've heard of the Java programming language and the Python programming language, but they're actually using the term block-based graphical language now, and that's blocky coding. We call it abstraction. In teaching, we're used to abstracting information, taking large chunks of difficult information and put it into understandable chunks for students. Some teachers make music plunk or blocks out of it. Some make acronyms, but we try to abstract it to an easier level so that they could quickly get their head around it. And so this blocky code or graphical language is how we abstract computer science. Beautiful. So if you're going to teach it, this is how you should do it. Here's another clip from Dan.
So I'll give you some more context. This is the high school advanced placement space. For those of you who don't know, the College Board, a nonprofit, offers high school courses and offers an exam. Many of you have taken them. Many of you are now accelerated through your UC Berkeley degree because of AP courses. Although there's now a pushback for schools who don't want to have any APs, and there's a whole conversation behind that. So this is a number of the students that took the AP exam back in 2012. And you'll see that some numbers are really, really high. I mean, the millions, history and English. And you can imagine that history and English are paying for some of the lower enrollment courses because it costs a fixed amount of money just to kind of pay a development committee to make the exam and to do all this and to fly them out. So it costs a fair bit of money. And computer science used to have two different courses, by the way, computer science A and computer science AB. Computer science there, it really should be computer science A is what's left. AB had about 5,000 folks, and it was losing money. It was in the numbers of people take Latin. It was really, really small. And basically, history and English were paying for computer science every year. And they eventually canceled AB, which was the second course. They left only A. So this is the number of students taking this as compared to the whole big picture. It's a really small number. And within that number, maybe it's hard to see that box, 15% of that tiny box are young women, and only 8% are students of color. And so the College Board at some point released some numbers which had said that the computer science is the most gender-skewed AP course they had ever had. In their history of AP courses, which goes back quite a few years, they've never had one as skewed as that, and the numbers are 50%, 19% women. Just really, really bad. So there's something broken. There's something got broken there, and we had in 2008 a big conference. Should we try to fix CSA or should I do something else? And the conclusion was do something else, and I'll tell you that in a second. So this is kind of the motivation, computing in the literacy of the 21st century, but as it says, only available in 5% of the schools. So there's something really wrong that we're not getting computer science to these schools. And where is computer science available? What schools is it available in? It's typically available in suburban, affluent schools, typically white and Asian suburban schools, not available in rural schools and not available in inner urban schools. So we got to get computing out to those schools. So how do we do that? How do we make a change? And Jan Cooney, one of the leaders of this movement, was told, don't get into high school. If she was in broadening participation, she was the program manager, and she was told, she was advised, and the person before her, don't get into high schools. If you want to change high school, you're going to be fighting 50 different fights, because
So that was some more reasons why Dan got into it, and some of his data on it. So currently, remember my computer science A class. This is the class after the introductory class, or this would be the class after Dan's class, Beauty and Joy of Computing. Our computer science A class still only has 3 out of 13 students. We have 13 students district wide, and only 3 are female. So we have a real problem. Here's some more solutions.
Grab students in. This was the percentage. I'll walk up to show you. This is the percentage of women in Intro CS since the university has been keeping records. We try to go back to them, and they did a data run. This is 1993 spring, the first year they kept gender statistics. This wiggly line is our first course for majors, 621 A, B, and C, okay? And notice that they kind of wiggle around 20%. They're a little lower, a little higher, about 20%. These 2 lines are our first course for non-majors. You see here it's CS3 and CS3L. That became lab-centric here. But notice that's averaging about 35, right? It's about 35. So those are the numbers. Roughly we're at about 20 down here and 35 up there, never really eclipsing any higher than 40 or 45-ish. Well, we introduced CS10, and those are our wiggle numbers we had ever seen. So we were wiggling already starting higher than we ever had. This is the first semester. We were already higher than we'd ever had. It dipped below because some semesters here, and then this is still me. I'm constant. I'm the same instructor here. And all of a sudden, at one semester, I looked at the numbers and said, "This is amazing. We're at 52% women." I could not believe it. And so,
all right. So there is not solutions. That is more data on the problem. And so we must have a solution for this. I told you we'd get back to this name, and back when 2004, 2006, we were seeing reduction of numbers in computer science. And I was doing the upper level classes. We had other teachers doing the lower level classes. And so when I dipped down to look and see what was going on lower levels, the first thing I noticed was the name. We had a class called Introduction to Computer Applications. Doesn't that just sound fun? No. So I thought, first thing, let's change the name of it. So like Dan changed the name of his course to Beauty and Joy of Computing to try to get a better synergy, I changed mine to iClass. That was during the time of iLife. So we had iMovie, iTunes, iDVD, all that iStuff that Apple was doing. So I just said, hey, let's do it iClass and see if it's more interesting to students. And we had a good run. We actually had 4 or 5 sections of that class filled, and kids really enjoyed the course. So we now changed our course again to Computer Science Principles. That's Dan Garcia's class, high school style. The AP calls it AP Computer Science Principles. My school calls it AP Computer Science Principles also. But is that where we're going wrong? Is that a bad deal? Remember, we right now, currently, the amount of females we have in that class are at 1993 standards. So we still have some looking in to do on some of the problems of computer science and its courses. All right, so to come up with a plan, this is what I came up with. Buildbox. When I saw Buildbox, all this stuff was ringing around my head, and I saw it. I said, ooh, that's exactly what we need. Something robust but simple, something abstracted, something beautiful, something that could be put into the world. And this is where I came up with Buildbox. I'm going to offer both Buildbox 2D and 3D. Buildbox talks about trying to catch a trend of game design in the App Store, and sometimes people want 2D, sometimes people want 3D. The 2D has no programming to it. The 3D has actually coding. You could actually code to it. So you could hit different levels at different times. And of course, it's because children learn most effectively when they are playfully engaged in constructing meaningful projects in the world, and that's Papert. And that's exactly where we need to be, and that's where I'd like to take us. This is a little video on Buildbox, just to show a little bit of what it looks like.
So this is Buildbox, the most advanced drag and drop game creator ever made, and it's easy to use. Our vision of this software was to make a game as easy as creating a PowerPoint or Keynote presentation. Literally just drag and drop images into the software, arrange them, and create a game. And that's exactly what we've done. So the first thing you'll do with Buildbox is grab an image, hover it over the software, and then drop it on the drop wheel. Here you'll either choose a character if it's a character, an object if it's a platform or an enemy, and then also you can choose a power-up or a background image. Now you have full control over these objects. You can duplicate them, you can arrange them, scale them, rotate them, or change their properties. We've also got an easy-to-use active menu system. You can drop buttons, images, or create invisible buttons to use for a touchscreen. One of my favorite features is the live preview. All changes you make in the Infinity engine, whether it's gravity, how fast a character jumps, how fast the game moves, changes in real time in the live preview. You literally can tweak your settings and see them immediately.
So that's a little introduction into Buildbox. It's beautiful. It's very abstract. It has kids just using sliders, and now remember, every time they're using those sliders and every time they're dragging those blocks of code in, there's some real computer science, some real programming language being put behind there, and it helps me as a teacher describe when I'm in text-based what's really happening. I can tell them, remember when we dragged this object to the scene and this instance of the object or these object properties. So it really kind of rings home with them, and I think it's really going to help out. On my pathway, I have, there's my 4 classes, and I originally started thinking maybe since it's no coding, then my beginning classes could do Buildbox 2, and then the next level up could do Buildbox 2, and then touch a little bit on Buildbox 3 with CSA, and then by just a strange mistake, we only put Buildbox 3 on at the original time, thinking that was the latest version. And Buildbox 3 again has the coding, and I gave it to all my classes, and all the kids were doing it. Okay, girls and boys and all of them, freshmen through seniors, they all were able to maneuver through Buildbox 3D. So after a while, I just started saying, you know what, they all could do all of them, just something like that. So we just have 2 softwares ready to them to take on. So if the trends are more of a 3D game, they can use 3D, and if they're a strong coder, they can use 3D. If they're not a strong coder, they could use 2D, but you could still produce a game in 3D with no coding experience. You don't need code to do any code, right? But if you're a strong coder, the only place to code will be 3D. So anyway, it just turns into the spider web. Just use whatever you think is best. They both come with these great looking templates to start the game off. You add graphics and textures, and the kids have a real good time with it. And I want to actually show some of the games that the kids got done, and some of them did them in less than 3 weeks. So it's pretty nice, pretty manageable games that are actually you could actually put in the store in 3 weeks time, right? So anyway, that's my solution. It's a very small, just one solution to a bigger problem, and it's just a small solution. We all have to keep looking at this and seeing what's going on with this subject, because if it is literacy of the 21st century, we have to try to meet kids where they are at, right? So just trying to make you great, help you innovate. Thanks for watching. In the comments, tell us where we're going wrong. Give me some feedback. What can we do better? Where am I off on this? Give me what do you do? And don't forget to subscribe, and I will see you next time.